Yeah, I hope those made sense as you worked those through. The answers were there too that you can check. I want to add one more sort of rule. Basically, what we're saying is when you're balancing compounds, you're going to take the elements that are listed and write down their symbols. Then look to see in the periodic table if they're in a column that has a charge at the top. Write those charges at the top. Those are called valence numbers. And then you're going to balance them by using their valence numbers to help you figure out how many of each atom you need to have the same amount of pluses minus charge. Now, you may have recognized in your periodic table here that you don't have any charges at the tops of these transition elements. That's because they can be many different charges, sometimes +1, +2, +3, +5. And so you're going to need some way to determine what is the value. And that method you saw yesterday, or the previous little lecture, is given usually as a Roman numeral. That helps to tell you what that charge is going to be acting like. So in this case, iron is going to be acting like a +3. Chlorine is a -1. Okay? And you can then say, well, I need 3 chlorines to balance out my 1 iron. Now, what I want to do is to say, those are the way that transition metals are going to work. You're going to see them as Roman numerals. But there's also a second group of elements that I want you to understand, and they're called polyatomic ions, many atoms that act as one thing. Okay? And usually they have a charge. So I would say take a sheet of paper, like a 3x5 sheet, or just tear a half sheet of paper out of your notebook and write this down. These are the most common. 85% of the problems you're going to do are going to be with these particular ions. Know what NH4 is, that it's ammonium and it's a +1. Know that the 2 phosphate and phosphites are PO4 and PO3. Usually you'll notice that if there's 2 8 and ites, the one with more oxygen has 8 and the one with less oxygen has ite. But they're -3s. You should just these ones you should have down. If there was anything it could get you to do is memorize one, that'll help you to do most of the problems we're going to do. If you just say, oh yeah, I recognize that automatically as a polyatomic ion. Otherwise, it'll start to get a little tricky. Okay, so you should know these. There's probably 15 of them or so, maybe a little more, 18 of them. And that you should know that the charges and these. And if you have the card next to your sheet of paper when you're doing these exercises, that's fine. That'll be a great way to get started learning these. If you write them down 2 or 3 times, you may actually get them down without that much extra work. Last, if you're using these as elements like we have in the bottom of this example here, you may have started to realize all I need to do when I have these polyatomic ions here is just to cross them over, and they'll actually help me solve this problem. So if I take aluminum and carbonate, I'm going to write them over here. Aluminum, carbonate. Okay, carbonate is right in here. It's a -2. So that's a -2 charge, and the aluminum is a +3. But watch what I can do is I can take that charge and say, well, that -2, if I use that as a subscript for the aluminum, I've got 6 positive charge. Now I take that 3, and I'm going to use that for the subscript. And I have to put any polyatomic ions need to be grouped. And in other words, when I put a 3 out here, I mean 3 of everything inside. 3 of the O3s, 3 of the carbons. So you got to put that in the inside, okay? But you can use those charges as the subscripts. So, for instance, calcium is a +2, sulfate's a -2. Do I have to do anything on that? No, they're balanced. The plus and the -2 are balanced. Iron, I got another Roman numeral, so that's got to be a +3. Chlorate is a -1, right up here. Okay, so how many chlorates do I need? I got to put them in parentheses, and I can use that as a 3, and I'll use this as a 1, although we don't write 1s. So Fe, we'll just take that. Oopie, come here. Let's get rid of that. Delete. Okay, FeClO3 in parentheses 3. And the last one, strontium phosphate. Strontium's got a +2 charge from the periodic table. You see it's in that column. And phosphate's a -3 charge. So if I cross those over, I need 2 of the phosphates, and I take this 3 down here, and that'll help you in most cases, except for when they're 2s. You know, they're both the same number, +3, -3, +2, -2. You don't have to cross those over because they're already balanced. Okay, so let's try those next worksheets where you're using polyatomic ions and transition metals. That should give you good practice and finish up this idea of balancing.